Our topic is on torsion of thin-walled tube. So, the torque applied to thin-walled tube can be expressed as torque is equal to 2 times the area times Q. You have to take note that, so we have here the illustration for a thin-walled tube. So we have the center line wall. So and you have the thickness denoted by T, small letter t, to represent our thickness. So this will be the formula that you will be using for the torsion that is considered on a thin-walled tube. You have to take note that T is in Newton millimeter. Our area for this one is the area that is enclosed by the center line of the tube, and that is shown in the stripe filled portion. So this is the area that we are being considered, the one that is in stripe filled portion. And our Q is the shear flow, which is in Newton per mm. So for this one, for the average shearing stress across any thickness, T is equivalent to this equation. Shearing stress, tau, is equal to Q all over T, which is equivalent to T all over torque all over 2 times the area times the thickness. So therefore, torque T can also be expressed as 2 times the area times the thickness times the shearing stress. So let's have a problem number 1. For the first problem, a tube which is 0.10 inches thick has an elliptical shape as shown in our figure. What torque will cause a shearing stress of 8,000 psi? So for our problem, we have an ellipse for our figure, and for the ellipse, of course, to solve this one, we have our torque for our solution, which is actually equivalent to, so torque is equal to, from the formula, 2 times the area times the thickness times our shearing stress, which is our tau. So for this one, our area, you have to take note, this is an ellipse, so area is equal to pi a times b. So for this one, this is actually 3 inches. This is 2b, which is equal to 3. So our b here is 1.5. This one is 2a, which is equal to 6. So our a is equal to 3. So if we try to substitute this to our equation, our area would be pi times 3 times 1.5. And this gives us the value of 4.5 pi inches. Or simply, we can have the value for that for our t. Our t here, of course, which is the thickness is 0.10 inches, and we are going to solve for our torque. So our allowable shearing stress is 8,000 psi. So from our formula, torque is equal to 2a times thickness times the shearing stress. We simply have to substitute. So we have 2 times 4.5 pi multiplied to our thickness, which is 0.10, and multiplied to our allowable shearing stress, which is 8,000, and this will gives us 22,619.47 pounds inches, or this can be equivalent actually to 22.62 kip inches. So this is all for our problem number 1. Problem number 2, a torque of 450 pounds-feet is applied to the square section as shown in the figure. Determine the smallest permissible dimension A if the shearing stress is limited to 6,000 psi. So for this problem, we have a square figure. You are given with a square figure and you have an allowable shearing stress 6,000 psi. You are required to compute for the dimension of our square. So we will be solving for our A. So for our solution, of course, T is equal to 2 times the area times the thickness times tau. So therefore, if we're going to have the area, we have to take note that T here is 450 pounds-feet. So since we are given with the shearing stress, which is in pounds square inch, so our torque will be converted. So 450, convert this one to inches, so times 12. And so that we can have a unit of pounds inches. So our area here will be equal to A squared. And of course, our shearing stress allowable is 6,000 psi. So for this one, we are going to substitute our torque value, which is 450 times 12, which is equivalent to 2 times the area, which is A squared, multiplied to the thickness, which is 0.10, and multiplied to the allowable shearing stress, which is 6,000. So if we try to simplify, we can solve now the area, the A, which is this side or the dimension of the square, which is 2.12 inches. Problem number 3, a tube 2 mm thick has a shape shown in our figure. Find the shearing stress caused by a torque of 600 Newton meter. So we have here a figure. So it composed, actually, this is a composite, which is composed of a square and is semicircle on both sides. So of course, from our formula, T is equal to 2 area times the thickness times the shearing stress. So basically, our A here is equivalent to pi. That will be the area of this figure. So that will be square and 2 semicircle. So it makes one circle having a radius of 10 millimeters. So using the radius value, so we can have the area of the square, which is pi r squared. So we have to take note, this is now this half of the circle, and half of the circle will make one circle. So if we're going to have the area of a circle using the radius, that will be pi r squared, and the radius is 10 squared, plus we have here is square from this portion. So that will be 10 times 20, 80 times 20. So 80 times 20. So this will give us 1,914.16 rather millimeter squared. So that will be the area. And of course, our thickness is 2 mm, and our torque is given, which is 600 Newton meters. So simply have to substitute to this equation. So that will be 600 is equal to 2 times 1,914.16 multiplied to the thickness, 2 multiplied to the shearing stress, which is unknown, and our shearing stress, which is the unknown, is 78.36 megapascal. So we have now our shearing stress, which is 78.36 megapascal.